me just fix one little thing here. Okay, I think I got that there. All right. And making sure everything moves. Yes, everything moves. Okay. All right. Well, first off, let me introduce myself. My name is Lance Zurich, and I am the product manager for the Fischertechnik division over here at Studica. And today I'm going to give you a brief overview of the Fischertechnik STEM Prep and STEM Engineering sets. Now, these sets were designed to enable educators to provide students with a project-based, standards-focused curriculum program involving inquiry, design, and problem solving. And the curriculum for each of these sets was created especially for Fischertechnik by noted educator and STEM expert Tom White. Some of you may have heard of him. If not, you're going to hear about him a little bit later. So let's continue. So what is STEM education? Of course, as most people attending this webinar would know, it's an acronym, and STEM, of course, stands for science, technology, engineering, and mathematics. And these days, it seems everywhere you turn, somebody's talking about the importance of STEM education, and the reason for this is really pretty simple. The demand for scientists and engineers is expected to grow at a rate far exceeding any other occupational field, and while at the same time, we still don't have nearly enough students pursuing careers in these areas to meet this growing demand. Consider this, the United States Department of Commerce projected in the decade leading up to 2018, up till now, that STEM occupations would grow by 17% compared with just 9.8% growth for all other occupations. Now this graph has a slightly different set of projections made for the period of 2010 to 2020, which made even more dramatic predictions. Now, some of this may not sound or look so bad just on the face of it, but just to put it in a better perspective, think about this fact quoted by J.D. Chesloff in his Education Week piece from March 5th of 2013. Quote, across the country, across all occupations, there are 3.6 people for every one job. In STEM fields, there's one person for every 1.9 jobs. Employers can't find the talent to fill these jobs, which is even more surprising considering that the U.S. Census Bureau recently reported that the median salary for engineering majors was the highest of any profession, end quote. Now, as Chesloff goes on to state, quote, supply is low and demand is high. There's a mismatch between projected future jobs requiring STEM skills and the projected supply of qualified workers to fill them, end quote. Now, this same need was voiced by the bipartisan Congressional STEM Education Caucus in their report on the importance of STEM education. They determined that STEM education is necessary because it helps to provide the scientists and engineers needed for future development, provides the future workforce with the skills required of a high-tech world, and it builds the foundation for scientifically literate voters and citizens. Now, as such, STEM education isn't just a matter of personal development to enable students to land the best-paying jobs. It's really also a matter of national security. On every level, the world around us is changing at a dizzying pace. Now, at the risk of being redundant, STEM education helps us, both as individuals and as a nation, to understand and keep up with the rapid changes in technology. Changes which, in turn, are altering the demands and the scope of industry. And obviously, if we as a nation are to keep our stature and position on the world stage, this requires us to keep pace with the rapid developments occurring all around the globe, where countries like China and India are making major investments in state-of-the-art infrastructure. Now, most experts agree that one of the most effective methods for teaching STEM is by providing exercises where certain results will occur, and the students have to discover why they occurred, or where students have to find a way to achieve a specific outcome. Now, they do this through experimentation, through research, and through trial and error activities. In short, they find the answers to these questions through the use of hands-on, project-based learning. And that brings us to the focus of the webinar, the Fischertechnik STEM Prep and STEM Engineering sets. Now, as I mentioned before, both of these sets have been designed to provide a guided, project-based experience, complete with detailed curriculum, all built around the unique Fischertechnik building system. So, what is Fischertechnik? Well, just to provide you with a little bit of background, Fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets designed to simply stack, Fischertechnik was created with more of an engineering mindset. The core building block in the Fischertechnik system is unique in that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together to lock in place, and there are hundreds of different parts available which also help you to address very specific design needs. Now, Fischertechnik was developed back in the 1960s by German inventor Arthur Fischer, noted for countless innovations used in the construction and automotive industries. Among some of the things that Mr. Fischer was noted for were he was the inventor of synchronized flash photography back in, I believe, 1946 or 1947. And as you see him holding over there to the left side of the screen, he was one of the inventors of the nylon wall anchor, which is basically used with a screw or a bolt or what have you to help secure a heavy object to a wall. Not only was he one of the inventors of the original wall anchor, which of course we've all used variations of them at home, putting up shelves and what have you, but his company, the Fischer Group of companies, makes many types of different wall anchoring devices used in construction, chemical anchors, what have you. And as I mentioned, he did also, the company's involved in a lot of things with the automobile industry as well. So this is where Fischertechnik is coming from. Now, I'd also like to mention that Fischertechnik was the very first construction set to offer students the ability to build and program their own robots, and that was using the original pre-Macintosh era Apple computers, like you see one of over there. Now, almost since its inception, Fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related concepts. These are, of course, things like robotics, renewable energy, mechanics, pneumatics, and so on. Now, Fischertechnik has also been used by numerous companies, and these are companies like Porsche, Daimler Chrysler, and BMW, just to name a few, for industrial simulation and training purposes. Now, as such, more than being just something that students are only going to use for a year or two in their development, Fischertechnik is really designed so that students can grow along with it. As students progress through their academic careers, they can also progress through the levels of Fischertechnik education solutions which are available. Now, the Fischertechnik STEM Prep and STEM Engineering sets are among the latest members of the Fischertechnik education family. STEM Prep is designed for exploring essential aspects of technology with a focus on physics, robotics, energy, and power. And STEM Engineering is designed to provide a comprehensive overview of robotics, coding, and automation systems. Now, each of these STEM-focused sets is designed to provide all of the materials you'll need, and these are both the physical materials and the instructional materials, to enable teachers to offer a complete, daily, STEM-focused classroom experience. STEM Prep contains over 75 academic hours of curriculum material, and STEM Engineering contains over 150 academic hours of curriculum material. So what does this mean? Well, essentially, if you offer your students a STEM education class of a single 50-minute period each day for 5 days a week, this would provide you with enough curriculum material with the STEM Prep set for half a year, and with the STEM Engineering set for a full academic year. Now, the curriculum for each of these sets comes in a handy PDF format. There's a curriculum PDF for the teacher to conduct the class, and there's also a separate PDF that can be shared with students, which acts as a guide for all of the class activities, and it, basically helps keep everyone on the same page. Now, to assist new users of the Fischertechnik system, the curriculum also includes a helpful tutorial section. Now, this section will provide guidance on, for example, identifying the many types of parts that are included. It shows you how these parts fit together, and it also walks users step by step through the building of a simple model. The STEM Prep and the STEM Engineering sets are also designed to be somewhat dual function. And what I mean by that is that besides being designed so that educators can conduct a curriculum-centered, project-based STEM class, they also include the full-color step-by-step assembly manuals in PDF form from various popular Fischertechnik STEM education sets. Now, these assembly manuals can, of course, be used as a reference when students are going to create their own original projects, which they are going to be required to do throughout the course of the project-based curriculum. But in fact, the STEM Engineering set also allows you to build all of the models that are found in Fischertechnik's 3 most popular robotics sets. And the STEM Prep set allows you to build all of the models found in 9 different Fischertechnik STEM education sets. And we're going to discuss specifically what's featured in there a little bit later here. Now, as I mentioned at the top of the presentation, the curriculum material found in the Fischertechnik STEM Prep and STEM Engineering sets was designed for us by a man named Tom White. Now, Tom is a noted educator who's been involved in STEM education since the 1970s. He's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is involved with the STEM-focused Southern Regional Education Board's Advanced Careers Program, which launched in 16 states back in the fall of 2014 and continues to add programs and participants every year. Now, this is not the first time that Tom White has created a curriculum around Fischertechnik. Now, besides also being the creator of the curriculum that's used in our elementary-focused Introduction to STEM series, Tom has also incorporated Fischertechnik in several educational programs that he's designed over the years. Now, Tom believes that Fischertechnik is the ideal construction set for an engineering-based curriculum program, and he's given us several reasons for that. First, he likes the fact that the materials can be used and reused. Things that are built can be easily taken apart and reassembled into something completely different. And this also makes it much more economical than, let's say, just purchasing an expensive piece of equipment that might only be used for one or two experiments or projects, then put on a shelf to get dusty until the next semester. And it should also go without saying that Fischertechnik, with its wide assortment of very specific pieces and components, offers almost limitless creative opportunities. The curriculum for both the STEM Prep and STEM Engineering sets has been designed to address some of the most widely recognized academic standards currently in place. Now, while we cannot meet state-specific standards, of course, if your state has certain standards, we probably address those in some way, but we may not address those specifically. But the ones we do address specifically include college and career readiness standards for math, science, reading, and writing, the NSES content standards, the standards for technological literacy, the ISTE standards, and the next generation science standards. Now, when Tom White put together the curriculum for these two sets, he had several goals in mind. First, based upon his observation that various types of teachers have different strong points. For example, he sees his own strong point as being the creation of curriculum such as this more so than conducting a lecture. And so he focused on creating a curriculum that would provide a broad foundation of tools for all types of teachers to be successful in providing this class, so that they could instead focus on the needs of the students. Now, the materials have been included at the beginning to familiarize new users with how the system works, and each section of the curriculum clearly spells out how things will be covered in that unit. Essentially, this was designed to act as a turnkey solution that would provide everything that teachers would need in one place. Now, in short, the curriculum was designed to provide a clear roadmap for both the teachers and the students, with the learning facilitated through the extensive use of projects and problems for the students to address. Now, the goal was also to enable teachers to provide students with engaging curriculum-based projects that had an authentic objective in solving real-world problems, and which contain embedded academics. Now, the detailed curriculum with each set, if followed, will allow educators to provide what is essentially a standalone project-based STEM education class. Now, of course, as I mentioned before, each set also includes the step-by-step instructions for building the models found in various topic-focused Fischertechnik STEM sets. So what students experience? Well, under this project-focused model, students are told up front what they will need to learn and understand. They're given a real-world scenario where they will take on the role of a professional working on a team, which has been presented with a design challenge they must devise a solution to, and they are then provided with different tools and pathways to help them achieve this goal. Now, among other things, students must perform research, and that's research both in and outside of class. And they have to learn the documentation process, for example, creating a design brief, maintaining a digital engineering journal, and so on. And among other things, students must perform research, and this is going to be research both inside and outside of, I'm reading my same line again here. They're going to collect data. They're going to learn firsthand how data acquisition works, how to process data, and how to put the data into graphs and formats, and so on. Students are also given a technical literacy task driven by the project. Now, fulfilling this task will require them to gain the knowledge and the tools needed to address it through research and exploration. Students will perform a series of specially designed enabling activities through which they will acquire the necessary science, math, and tech-based skills. They're going to devise solutions to their tasks and create prototypes using the advanced Fischertechnik modeling system. And they're going to then create and install the programs needed to control their prototypes. They're going to document every step of the entire project and formally present their findings, including a demonstration of the prototype in action. Now at this point, we're going to begin by looking at the sets themselves, and we're going to begin with the Fischertechnik STEM Prep set, which you see on your screen here. Now the prep in the name, like STEM, is an acronym, and it stands for Physics, Robotics, Energy, and Power, which are the subjects focused on in this set. Now each set is designed to be used by a team of 2 students at a time. The set contains over 2,100 parts and components, and this includes things like the Robo Pro LT software, a USB-powered control unit, an electronic module, a pullback motor, a solar motor, an XS motor, a mini motor, a compressor, 2 solar modules, a gold cap energy storage unit, an NTC resistor, a phototransistor, an LED, 2 rainbow LEDs, and hundreds of other parts, all of which come packed in sturdy plastic gratinal storage box. Now the project themes addressed in the STEM Prep set include the following: sketching and documentation, simple machines, mechanical systems, structures, the conversion and storage of energy, electronics, optics, digital communication, and programming control systems. And once again, the curriculum for the STEM Prep set is designed to provide enough material to cover 75 plus academic hours. Now the STEM Prep set also includes the step-by-step pictorial instructions culled from 9 individual Fischertechnik sets, and these sets include the sets focusing on drive systems, eco-energy, pneumatics, mechanics, Physics 1 and Physics 2, electronics, optics and light, and the robotics beginner set. Now the one little note, if you see the star up there by the eco-energy, that aside from 5 models shown in the instructions for the eco-energy set, which incorporate an optional fuel cell add-on, which of course can be purchased separately if you wished, all of the other models shown in these instruction PDF booklets can be built with the parts found in this set. As such, even if you didn't wish to use the curriculum for whatever reason, the STEM Prep set would still be a convenient and affordable way to have the building and learning options from these 9 sets in one box at a very affordable price. Next, we're going to look at the STEM engineering set. Now this set can either be used as a follow-up to STEM Prep or totally on its own, and it's designed to provide students with a comprehensive overview of robotics, coding, and automation systems. Now this set is designed to be used by teams of 2 to possibly up to 4 students at a time. Now the reason this differs from the STEM Prep, which is focusing more on 2 students at a time, is because the projects in the STEM engineering will keep more students engaged at one time. They're going to require more things to be done with the research, the building, the programming, and so on that's going to be required. Now this set contains 890 parts and components, and this includes things like the Robo Pro software, the Robotics TXT controller, which is a full-color touchscreen Bluetooth Wi-Fi capable controller, Fischertechnik AccuSet, which is a rechargeable battery pack with the charging unit. You get 2 encoder motors, a compressor, 2 phototransistors, 2 of the XS motors, a mini motor, 6 push-button switches, a color sensor, an NTC resistor, 2 LEDs, 2 solenoid valves, a vacuum suction device, and many other parts components. Once again, they all come packed in a handy and plastic gratinal storage box. The project themes addressed in the curriculum for the STEM engineering set will address the following areas: sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. Once again, the curriculum over here is designed to cover 150 plus academic hours. Now, there are also activities included to address the following areas that come up during the course of the curriculum. Areas such as sketching, schematics, Ohm's law and power, an introduction to using the RoboPro software and using the TXT controller, flowcharts, working with open loop and closed loop programming, digital branching, edge triggered versus level triggered, logic gates, combinational logic, analog branching, variables, subprograms, data, sensors like the digital switch and the digital photo transistor, analog sensors including the NTC resistor and the color sensor, an introduction to using the USB camera, using the camera to detect motion, doing color detection, creating a ball finder, which is where you use the camera as a vision system on the robot, using the line tool, working with the encoder motors, building the control panel, working with pneumatics, positions, recording positions, and utilizing existing programs and subprograms. And this set also includes the step-by-step assembly instructions found in the following 3 Fischertechnik robotics sets: the Robotics Advanced set, the Robotics and Electro-Pneumatics set, and the Robotics in Industry set. Now, once again, if you wanted to work outside of the curriculum, this set will still contain all of the parts, the software, the controller, the power supply, etc., so that you can build any of the 22 models found in these 3 sets. This is going to include things like color sorting machines, pinball machine simulations, various mobile robots, robotic arms, and so on. Now at this point, as we've touched upon what is covered by each set, I think it's going to be most useful to show you just how the curriculum for the STEM Prep and STEM Engineering sets is structured. Each unit of both the STEM Prep and STEM Engineering curriculum contains a roadmap of sorts where each of the following elements are addressed: the purpose, the concepts, the student deliverables, assessment and evaluation materials, an outline, the standards, an authentic project scenario, a daily teaching plan, supporting activities, and resources. Now, to put this into context, let's look at the curriculum that accompanies the STEM Engineering set. Now again, while we will focus on material only found in this particular set, the structure of the units and how subjects are addressed in each of these curriculum pieces is essentially the same for both. Now here you see the table of contents for the STEM Engineering set. Now the first thing I'd like to note is that before we get into the specific units, and if you look closely, you'll see that just on this page we have the listings for the units on sketching and documentation and basic electricity. That before we get into that, there's a section that will help any new users of the Fischertechnik system to quickly get up to speed. Now once again, the core building blocks in the FT system are designed to attach from all 6 sides, and many of the other parts are designed for very specific purposes. Now, as this is a little bit different than the simple stacking construction of many other construction sets that you may have worked with, we've included this section right up front to help increase both your comfort with using the system as a teacher and also your students' comfort with using the system, and to allow you and your students to get the most from your building experience. Among the things that are going to be included here are a section showing you how all the parts fit together and discussing the pin and groove assembly method that's used, a section showing you how to identify the various parts that are used from the core blocks to the more specialized parts, things like clip axles, girders, rivets, angle pieces, and much more. There's a section that shows you a picture of every piece that's contained in the kit, along with the name of the piece, the part number, and the quantity. And for those educators who are new to an approach such as this, there's also a chapter specifically discussing project-based STEM education. Now on that note, let's jump ahead to a sample unit just to explore the structure which we discussed. Now this unit, as you will see, is focused on programming. And right over here, the picture that you see at the top of the page is a graphic representation of the RoboPro software. Now as you're going to see in the close-up, of course, RoboPro is designed to use icons that represent the different actions, which students arrange in a flowchart manner to create the programs for each robotic model. Now, RoboPro is great because it allows students who may not have any prior experience with programming of this sort to quickly become comfortable with doing so. And at the same time, it also helps to familiarize them with the core concepts that are going to be found in all types of programming. Anyway, as you'll see, right under the unit title, we also have what's called the purpose of the project. And this is the section that helps to spell out for students the answer to that eternal question, why are we doing this? and as well as what skills we hope to see them develop here. Next, we have the concepts to be addressed in this unit. And these are the big ideas that students should learn from this project they carry with them that will be useful and vital for them to understand and know, not just today, but to draw upon as they move forward in STEM fields of study, and of course, we all hope, STEM-related careers. This is then line, and here it's spelled out more specifically what's going to be covered in the unit ahead. Now, as this particular section again is focused on programming, you're going to see that we touch upon areas such as the methods for writing programs, for example, flowcharts or word problems, various program characteristics, open or closed loop, branching, digital, analog, subprograms, and so on. Now, next we enter the section where each of the specific standards to be met by this particular project unit are spelled out, which of course helps provide the educational justification for the project itself. Now, while we would love to have standards for every individual state and school district represented, as I mentioned before, such an approach, unfortunately, is a little bit unrealistic. But instead, what we've done is we've selected the most universally accepted standards used in the United States today. And this is going to include things like the college and career readiness math standards, which are followed by the reading standards for literacy in history and social studies, as well as the writing standards for literacy in history, social studies, science, and technical subjects. After that, we have science standards, beginning with the NSES content standards for K-12, the standards for technological literacy, followed by the ISTE Foundation standards for students, and the next generation science standards. After this is the assessment section with links to both general course rubrics as well as rubrics related to the specific unit. After that, we have the essential question. And this can be thought of as the major idea that's going to be explored in a particular unit. And in this case, the question put forth is, how can we make decisions electronically and remove the need for human intervention? Now, the student scenario for each unit gives the students an opportunity to explore the unit's essential question. And the student scenario is always put forth in the form of a real-world problem that they are given to solve. And it also provides a clear answer to that question of where will we ever use this. Now, in this particular case, in this unit, students are asked to assume the role of a controller/programmer who happens to be working in a programming company that specializes in designing elevators and writing the control packages for their clients. Now, in this specific scenario, the student and the other students in the group will be required to create an elevator that will perform certain functions. For example, something like how will the elevator respond if it's, let's say, stuck on a middle floor and someone presses a call button on a top floor and a bottom floor at the same time, creating a protocol for how it's going to act. Now, the client's requirements are all going to be spelled out in this section, and the students will be required to create a program to address these specific needs. They're going to have to create a prototype, and eventually they're going to have to prepare a presentation for their fictional clients that includes a demonstration of the prototype and the program they've designed in action. Next is the daily plan. And the daily plan spells out the expectations as students work through the project in the student scenario. Now, each day of the daily plan acts as a guideline, and it spells out specifically what the students will look at today and what they need to accomplish. Now, you'll see that as different concepts are addressed, students are provided with helpful links, which will give them more information. For example, they'll have links that will show them what will be required in that design brief we mentioned, or the engineering notebook. Or, for example, how to install and use the RoboPro programming software. And we're going to look at some of these links a little bit after. But once again, each day has a different task to be addressed, an activity to perform, or a question to answer. For example, if you look closely at the bottom of the page here on day 7, you'll see that the discussion topic that they've put forth here is, how does my dishwasher know when the dishes are clean? And of course, your dishwasher doesn't know when the dishes are clean, but it's programmed to go through a certain way through certain cycles for a specific period of time. So here the teacher can lead a discussion where this idea can be explored. Now, other things covered in this unit, for example, will include things like how data is taken from a sensor and recorded, how files can be taken from RoboPro and put into an Excel format to be worked on and then put back into RoboPro, how to work on robotic positioning, and so on. Now, this particular unit on programming will continue on for a period of 35 days total. Most units won't be quite this long, but in any case, as students work through the daily plan and on their answer to the student scenario question, they're also going to be required to perform research. They're going to do a lot of trial and error experimentation while documenting the entire process, and this is why they have to maintain that design notebook in the engineering journal. They're going to design and build a working prototype, of course, using the Fischertechnik system, and also have to create and deliver a presentation of the prototype in action. Again, each day builds on the day before it, and each activity is subsequently more complex. And along the way, it helps to provide the information they're going to need to draw on to successfully complete the project. Now, what this does is it really helps to reinforce all the concepts for the students, and it ties everything together in a very organic and meaningful manner. Now, there are also various additional materials included at the end of each unit, and this will include things like vocabulary words, carefully selected web-based resources, Word documents, PDF files, and PowerPoints. Now, once again, each unit of both the STEM Prep and the STEM Engineering curriculum sets follows the same structure as we've just seen, including the standards, the rubrics, the daily plan, the resources, and so on. Now, as I touched on before, there are also numerous links throughout the curriculum for more information on specific topics, which are also collected in one section at the very end of the curriculum. For example, in the STEM engineering curriculum, we have activity links for what's required in a design brief or in an engineering notebook, a section on schematic drawing, another section on Ohm's law and power, a section on how to program a robot to detect motion using the camera attachment, one on digital branching, working with flowcharts, opened and closed loop programs, combinational logic, working with RoboPro, robotic positioning, working with sensors, working with data, using vision systems, subprograms, and so on. There's also a section where all of the rubrics are collected, and this means both the general rubrics and the project-themed rubrics. And finally, this is followed by a section containing those step-by-step assembly instructions that I mentioned before. Now, once again, the STEM Prep Sets curriculum will share the same structure, just with a focus, of course, on some different subject areas. Now, I'd like to share a few photos with you from one of the schools that's been currently using the Fischertechnik STEM Prep and STEM Engineering sets. Now, this particular school is Westfield Vocational Technical High School, and they're located in Westfield, Massachusetts. And the program over there at Westfield is being conducted by Dave Roberts, who's the science teacher. Now, what you'll see in these pictures are the students as they address the very first hands-on challenge, which is presented in the curriculum for the STEM Prep set. It's a basic challenge, but it's that of designing and building a prototype of a braking system as you might find on a racing bike. Now, students will work in small groups. Now, again, with STEM Prep, we really recommend that it's 2 students per set, but with STEM Engineering, you can expand this to groups of 3 to 4 students to better address all of the different activities that are going to have to be done, the research, the building, the programming, etc. Now, as you see from these photos, while the students are all working on the exact same project, there is no one right way. There's no single solution, no single answer for addressing the design challenge given in each unit student scenario. Now, some of these students are going to, of course, have design and build prototypes that work very smoothly and efficiently, and others are going to create models that, let's say, need more refinement. But the goal, of course, is to see how well the students synthesize all the concepts they're learning, and also how working in small teams, how well they can use their creativity and their problem-solving skills to make something that will most effectively answer the criteria given in the scenario. Now, I'd also like to mention another benefit of the STEM Prep and STEM Engineering sets, albeit a somewhat unintentional one. Now, a large segment of the students at Westfield Vocational Technical High School are what are classified as ESL students, i.e. their English is a second language. And these students happen to have originally come to the U.S. from Russia and the Ukraine. Now, in Massachusetts, teachers are required to take classes in ELL, English Language Learning, to help them meet the needs of these students. Now, Dave Roberts, who I mentioned before, is the teacher in charge of the Fischertechnik STEM programs at Westfield, told me a little while back that he has attended 3 different ELL training classes. And all 3 of these ELL training classes highlighted, in particular, project-based learning as an important learning tool for ESL students. Reason for this? Because design is really sort of a universal language. And working through the curriculum in this hands-on fashion helps to not only teach the students essential STEM-related concepts, but it also aids in building their English language skills because it helps them make the connection to actual processes and actions they can understand. Now again, what I've shared here are just a sample of some of the ways students can address this particular design challenge. Now, as I stated before, each subsequent unit will require more sophisticated designs, and each will build on what has come before. So just to summarize, each Fischertechnik STEM Prep or STEM Engineering set contains everything you're going to need. All of the parts, the software, all the assembly instructions, and a complete day-by-day curriculum. And the curriculum included in each set is yours to use this year, next year, and we would hope for many years to come. There are no additional fees. There are no subscription charges associated with this. Everything you need is included. And again, it's all reusable. You can build a model, perform the experiments, take it apart, and build something totally different. Of course, if you ever did need or want any odd parts or replacement pieces, you can purchase those pieces individually in whatever quantity you choose or need directly from our website. Again, the Fischertechnik STEM Prep and STEM Engineering sets are designed to make it easy for educators from any background to offer a hands-on, project-based learning experience for their students. And once again, this is what experts agree is one of the most effective methods known for teaching STEM concepts. Again, the STEM Prep set comes with everything you see here. There's over 2,100 parts components, the day-by-day project-based curriculum PDFs for both students and teachers with over 75 plus academic hours of material, as well as step-by-step assembly manuals from 9 popular Fischertechnik STEM education sets. Now, the pricing on this set starts at $7.99 per set, and of course, we have quantity pricing for classrooms available upon request. The STEM Engineering set, shown here, includes 890 parts components, and of course, this includes the programming software, RoboPro programming software, the full-color touchscreen TXT controller, sensors, motors, and all that, as well as student and teacher curriculum PDFs featuring over 150 academic hours of material and full-color step-by-step assembly manuals from the 3 most popular Fischertechnik robotics sets. Now, the pricing on this set starts at just $9.39 per set, but of course, pricing will come down when you get quantity pricing for classrooms, which of course we can provide that available upon request. So, you may have some questions. Give me a second to grab some water here because as you heard, I'm having a couple of mouth issues here, so give me a second. I will open up the lines and you can ask away.
Everyone can talk now.
Okay, if you do have any questions, as I've unmuted everyone, you could speak up, or, like I said, you can just feel free to type in the chat window there. Although, depending, I may have to do away with that.
What's going on?
Only the host can talk now.
Okay, it looks like that function was going to work so well with the background noise. How about if anyone does have any questions? As you'll see, there's a chat window that you can access in the toolbar for the Join Me application. It's right underneath the little word balloon thing. If you just click on that, you can type in any questions you might have. I will also give you my email address. If you did have any questions and for whatever reason you didn't want to ask them right now, you can send them off to me. And I'm going to type my email address right in here right now. lancez@studica.com. That is LANCEZ at STUDICA.com. If you do have any questions, you can either write me later. You can write me now if you want to write me in the chat window. You can write me tomorrow. Either way is good. So, going once, going twice on the questions. A 1, a 2. All right, I see nothing coming up, so I am going to go to the last slide. So on this note, I'd like to thank everyone for taking the time to attend the presentation today. If you'd like to know more about either the Fischertechnik STEM Prep or the STEM Engineering sets, if you'd like to request a quote, or if you'd like to speak to a dedicated educational representative, you can call us at either of the numbers you see on the screen right now. The first number is for our office in the U.S., where the number, toll-free of course, is 888-561-7521. Or if you're located in Canada, you can reach us at 800-561-7521. And you can also find more information on the program by visiting our special STEM Education Project page on the Studica website. And the address for that page is www.studica.com/FT-STEM-Lab-Prep-Engineering. That's rather a long URL, actually. We'll probably have to change that. Or you could also email us. And our general email address is stemlab@studica.com, or as I put in the chat window, you can email me at lancez, LANCEZ@studica.com. So once again, thank you very much for attending, and I hope you all have a great afternoon. Take care.